Hello, hello. No, shit, what did I press? Hi. And we are going today to work on kast again. Today is December 25. The plan is the same as before. We started yesterday on a refactoring into the functorial thing. This is not just refactoring, this is huge refactoring, which is touching every single piece of code, I guess. Wait, do you hear me clicking on the keyboard? All right. Go back to kast. Run the LSP support. Value unite is required but not provided. Okay, so this right now is about the value shape. Okay, so we have been refactoring things. This will lead to us moving the code around. One of the things, I'm not sure if I like it or not, but I don't know. So previously all of the inference logic was in this single file of 650 lines of code. That's almost all of the inference logic. But now, because every type is in its own like module, we're going to write the implementation of the inference for the specific type where the type is defined. So this logic is going to be like instead living in another place. Right? That's one thing that I don't like about this refactoring that I'm doing. But if I'm not doing that, then how would I go about it? Let's go first to the playground here. This is the example of how we are restructuring our code. So let's see. Module previous way, you know, or let's call it polymorphic way of doing things, right? So what we were doing before is something like this. We just have type A and we have type B. Type A is something that contains A, right? Let's say that it can be B of B, or it can be let's call it AB or A empty, for example. And B is B empty or BA of A, right? So this makes these mutually recursive types. This is just a simplified example, obviously. So why does this not work? Like one of the things that we are doing is we're defining, for example, the printing, right? So print is like a module where we define print A, which takes like A, right? and we define print b. Let's say something like this. So this means that all of the printing logic is written in one place. All of the other implementations are also encapsulated, like, and split by the thing that we're trying to implement, right? They split by logic, not by types, right? So only printing logic is in one place. All of the inference, right? Let's say infer A, infer B, all of the inference in one place, all of the printing is in another place, right? When we are going to rewrite this into this thing, we will have to basically for every type is going to instead live in its own module like this. The module depends on another module which describes the other type which is it depends on, right? So A depends on B. So module types A, let's just say that this declares some type, right? Well, so every type now we know how to print it, and we know how to infer it. Basically, this is not the correct signature, but it doesn't matter. Well, I guess we can say unite, for example, for inference TTT. So this is the signature that, I mean, in this case the signatures are going to be the same, but this is not necessarily so, I guess. So we specify the abstract types here and what are the operations that we must implement on them. Then when I define the type A, right, I need to specify the type T. So in this case, A is either empty or AB of B, right? And B is now BT. Now we need to specify print. This is going to be like function, let's say a empty, then we just don't do anything. If it's a B, B, then we say B print B, right? Let's make the implementation here, right? Function a empty, a B, B, print B, B, right? So this means that these were also recursive things before, right? That's how I was implementing that. This is like B empty, B A, this is print A. Okay. I mean, let's try the full implementation here for this simplistic example, right? So there's going to be function AB, match AB with a empty, a empty, a empty, a empty, whatever, fail. Can't unite. If it's a B, A, and a B, B, and say a B, unite B, a B. So this is also going to be recursive. Let track. This is going to be very similar. Instead of A, we say B, and BB is instead BA, and this unite A, right? So this is a very, very simplified example of what we're trying to do. Right, so we have printing, we have inference, we have two types which are mutually recursive. So that's the way we are structuring the code right now. And what we're trying to do instead is to do something like this. Okay, and then we say unite AB is match AB. Let's copy that. So unite B is going to be B unite AB, right? It's kind of simple here, yes, indeed. It is a lot more verbose, right? So this over here took 35 lines of code. And this is not finished yet. Let's actually have, hold on. Let's remove this old way.ml. I'm just going to move this completely into a separate file like this. Right, that's what we were doing before. Old way is the polymorphic. I don't know. Let's just say old way. It's fine. And this what I'm doing is functorial, functors, modules. Like let's call it new way. Okay, so this now says that non-rec A make B. So like this is because the signatures modules do not match. Yes, because A make, this returns the S, which is module types A. Is that right though? What does it not? We have a print T into unit, unite TTT. Print T into unit, unite TTT, right? Like this is correct signature here. But the signature of B probably does not. Yeah, when I hover here, it says B is sig end. But why is B sig end? BS. Oh, because BS is this, right? But BS should be just module types dot B. There you go. And this, I think, should work. Dune, exec, Camel Playground. So that works, right? Okay, so we have in the old way 35 lines of code. In the new way, we have twice as much basically. If this is even going to work, because like this keeps me having these types as abstract types. But maybe it is fine because like we are instead going to specify all of the different things, right? Printing, unification, evaluation probably will like also be here, and I don't know, all of the different things are going to be here, I guess. Or maybe we are going to actually duplicate that somewhere else. Like, for example, how do I construct the value of A, right? If I don't expose the constructors here, right? So I kind of really want this to be copy-pasted, where we know that type T is this, but the B here is not present, obviously, right? So how do I refer to type B? Because this must be recursive types, but we don't have the ability to have recursive module type signatures. Hello, penguin operator. So how do I solve this? We can just say that over here we have type B as abstract type, and we say like this, kind of. So it is going to be like abstract here, because this is a dependency of this module type. And the dependency of B. Can I have like, maybe we have like this, module dependencies. Module dependencies. I can do this. So this depends on B, right? Merry Christmas and happy holidays. Merry Christmas to all of you guys too. So we depend on B. You love camels too. Who doesn't love a camel? Right? Module depth, sig, and type A. So we declare the fact that B is this. This is B empty and BA of depth A, right? So when we make, or maybe like dependencies should be like module B sig type T, and is that better? So A depends on B, B depends on A. We say depth BT, depth AT, and then we could just say over here that module depth is struct module B is B. I can just do that then, all right? In case we depend more on just the type here. And then over here we have dependencies, struct module B, module A is A, right? Unbound module B. I love that the error message here is very good, specifying that the error is happening in file none. The signature mismatch. Signature mismatch. Wait, what do you mean signature mismatch here? OCaml restart language server. Signature mismatch. Type T is A empty or AB of A is not included in type T is B empty or BA of AT. Constructors have different names, A empty and B empty. Okay. A empty S. Wait. How did that even happen? Yes, that is indeed not correct, because this should be not A but B underscore. This is where we define B, and instead of BB we say BA, right? A unite, A print, This can be called A or whatever. Okay, and now the type signatures do not match because type T is B empty of BA of A, and type T is B empty of BA of AT is different. Why is it different? We have module type A has dependencies of on B. Of depth BT. Wait, why is this B here? This should be AT, right? There we go. It should have said that B is impossible to find. Okay, there we go. So that's how we structure it. Now we have already 86 lines of code here. So we specify the module type, and we specify that it depends on the dependencies. What if I say here... What if I say here that this is dependencies of A, right? So this is my dependencies. Can I say that this is just depth of module types A? So I cannot get like the type which is the inner type of another signature, but we can say a depth, I guess. We can say instead that this is a depth, and module type a depth is sig. That one, right? And similarly, module type B depth. We can also structure something like this. Module A is struct. So A, this over here is going to be called S. This is going to be called depth. This is going to be called depth. And then we say module B is struct, where we move this thing. This is depth. This is depth. This is S. This depends on A. So it's not module types S, it's AS, right? The signature of A. Okay. Module types. So this is going to be like A depths, right? This is my. So we're just bundling all the dependencies in a single thing, and we just declare it like this. This is going to be like depths BT, and this is going to be like BS depths. Module types B depths. Depths is depths. This is depths BT, depths AT, A print, unbound value A print. Oh, it's because A is declared over there. Yeah, that makes sense. We just say depths A print, depths A unite. Yeah, but like this is now wrong. So like when we depend, we still need to copy paste this, but we need to copy paste this without declaring the type, I guess, is the difference. So we have like 3 copy pastes now, right? Because how do I like print now, right? Because when we depend on this, we need to depend on the printable thing, which is why like bundling the dependencies doesn't really work, right? And we instead take dependencies separately after all, right? Fine. So this B module types BS, and then we construct the dependencies here manually like this, right? Module B is B, right? And then we now don't need to do module depths.b. So yeah, then Then we cannot bundle dependencies. This is the only issue. Or unless, like, if I want to bundle them, then we need to, like, construct a new thing, a new signature, which allows for bundling. All right, does this work? 92. So 3 times more code than before. Maybe that's not too bad, actually. But this means that we can actually, like, split our code into multiple different files too, right? So, for example, we are going... So right now we are having this, like, global like recursive functors and stuff. Let's try to remove this. So, for example, we have values, right? Or let's start with blocked values. Fine, let's start with blocked values. Let's have a new folder. Let's have a new folder. New way. I don't know. Let's call it new way. Let's have a new cast types. New way. Cast inference based case TST. Yeah, sure. Let's do that. So let's just have a file, right? What do we have? We have blocked values, right? Blocked values is something like this. So we are going to follow this structure from the OCaml playground. So first we need to, well, first we need to specify the module types, right? So we will have, I think we need to have, like, another folder here, which is going to be called module types, right? Cast new way module types. Let's do that. So we first need to declare the type of its dependencies and stuff. What are we going to expose? So blocked value is going to be here, right? So what are we going to expose? We're going to expose can I, so, like, this also contains, like, technically multiple modules, the blocked value and the blocked value shape, right? But can we just, okay, so we are going to say module type dependencies is something, right? That's going to be my dependencies. So blocked values, it seems like that we are depending on values here, right? So we at least should say module value. It should at least define the type of value, what the value is. So then we will have module type S, the signature of the thing itself. What are we going to be exposing here? So say module depths of type depths. Why do I actually expose this? Well, I mean, in order to use these dependencies in this type, yes. Okay, that's why we need it. Because I cannot have the wait, can I say module type depths? I cannot, right? So this is not a functor. So this is the way that we have it as an argument, kind of. Okay. So what do we define here? Dependencies, we just define the type, right? So we just say type T. And we are going to define the type here as actually the type. We're going, okay, signature S. Signature S will also have the module shape here, I guess. So this is the shape. shape is this thing. This is my shape. Shape. Blocked value shape. Field ref instantiate like so. Object ref blocked value t. Oh, and this is also recursive. I don't think I can have the inner module like this, right? If I do this, then I need to have the dependency on like the blocked value itself here, which is obviously not present. Value though is present. Value is from my dependencies because we depend on the value. And then the blocked value itself is this. Right, so this is the blocked value itself, but let's just say that this depends on cast types new way, and cast types new way is also going to depend on cast types new way module types, right? So it seems like module types have been unbound. No, unbound module. So why is this trying to compile then? Should I not even receive the June build? Like if this depends on that and that was not compiled, then why am I trying to compile that? Yeah, now we have the unbound module blocked value over here in file none. This is obviously file none. So we have a blocked value t here. So what is blocked value? Because this is also depending on itself. Maybe we have like module type. Maybe like let's have. I mean, we can also flatten this, I guess. Right, because we're going to have module type module shape struct. So shape depends on the value, and the signature of the shape is this signature, right? And then we have module like t, I guess, which defines the type itself. Then is going to be struct which has its own dependencies, right? So the type itself is depending on the shape s, depends on shape is shape s. And module type s is signature, where we have type t. So this is going, yeah, we have module steps, and here. So instead of saying blocked value t here, we're going to say dependencies dot blocked value t, because shape depends on the blocked value and on the normal value, right? So module blocked value sig type t. We only need the type from it though, so we do this. And S needs to have a module depths. Unbound module. So yeah, this also depends on the binding, right? So we have another dependency on module binding. Type T. So it's not binding, it's depths binding. And now this over here, let's call this fully, right? Blocked value shape. I mean, I can call it shape, it's fine. So this is going to be shape T, shape S. Shape S has the T, right? Oh yeah, it should be like depths.shape.t, right? There we go. And then like the type, I guess here is unbound. So this also depends on what, on the definition of the type. Type is sig type t, and well, I mean, and from the shape I also don't need shape S. I only need type t here, like that, right? So that is me defining what a blocked value is. Unbound module type. Yeah, this is like depths type t. Okay, there we go. This is green. So now we need to do this for all of the other types. But this only defines the type. I don't specify, for example, how to print it here. And so this is going to grow. Oh, and this is me only declaring the signature of it, right? Yeah, and now in the actual blocked value, now, can we now say no more STDs in the code? Here's the STD in the code. I don't think we can say that. Let me ask ChatGPT though. Like, what I'm doing here is like I feel like I'm reinventing the wheel. I'm like, do people do this? STD no longer appearing red. Yes, people do this, but only when they have backed themselves into a corner and accepted suffering and as a lifestyle choice. This is a mutually recursive functor plus module type plumbing pattern. It exists, it's legal. They want strong abstractions, bidirectional dependency, refuse runtime interaction, enjoy explaining their code to no one ever. Most OCaml programmers avoid this unless forced. Well, yeah, but I am forced to do this, right? What people usually do instead, collapse A into B into a single recursive module, use a single shared type, use first-class modules. How is a first-class module going to help me, though? I don't understand. Or admit the dependency graph is wrong and redesign. There is no way I can redesign this. 8. Hello, Spike. What do you mean 8? Hi. Merry Christmas. Show me example of other 10 gifted subs. Diggle. Thank you. Ho ho ho. Appreciate it. Show me example of other people doing this. Mostly very smart people, mostly in places where joy has already died. Hey Bales, gifted the sub back. Or were you not? Well, thank you for the gifted sub. Here are really recognizable examples of this exact pattern and why they did it. So the OCaml compiler itself, right? That's the, like, is that the only one? And Jane Street libraries, Jane Street does use this pattern, but notice the key detail, only in internal layers, never in public APIs. Well, I mean, yeah, it's not a public API, sure. CompCert, the verified C compiler. Wait, they have the C compiler written in OCaml, which is verified or something? Every serious OCaml programming language project eventually has a commit titled something like Introduce recursive modules to break dependency cycle. And the diff is like 5 lines of logic, 200 lines of module types. What do you do to GPT to make it this pessimistic? Hold on, I want to have like this, show me, like, link me to example of 0.4. I mean, yeah, this is what we are doing, and so, like, yeah, I guess I'm not the only programming language that is doing this, right? Recursive modules for programming. ICFP 2006. This paper discusses how recursive modules can be used to solve real problems, mutually dependent tree and forest modules. It even uses recursive modules and functors together to support modular programming in ML-like language. You can read the original PDF here. In that paper, you'll find that while real OCaml-like mutually recursive module examples with tree and forest that refer to each other's types and functions, the exact sort of thing that leads to modular rec functors like yours. A type system for recursive modules. Another PDF. The ML module system is useful for building large-scale programs. So I have basically, let's see here. You have module tree forest, which is a struct with struct TF. This is not OCaml, right? But this is some similar language. When building a large software system, it is useful to decompose the system into smaller parts or to reuse them in different contexts. Module systems play an important role in facilitating the factoring. The family of ML languages provides a powerful module system. Nested structures allow hierarchical decomposition. Functors can be used to express advanced forms of parameterization with ease code reuse. Which is code reuse. And in spite of its flexibility, the ML module system largely prohibits recursion between modules. This is a major disadvantage of ML when compared to object-oriented languages like Java. These languages have supported recursive definitions across class boundaries from the beginning, and this feature is heavily used in practice. We, ML programmers, enjoy strong type safety. Yet, due to the lack of recursive modules, we have to consolidate conceptually to separate components into a single module, intruding on modular programming. If we had both recursive modules and this flexible module language, we could enjoy a strongly type-safe programming language with an equally strong expressive power. Recently, much work has been devoted to investigating extensions with recursion of the ML module system. In this paper, we first review 2 examples. The first one, 2 recursive modules, tree and forest. Why does tree depend on the forest, though? I mean, I don't know what they're trying to define here. They respect each other's privacy. We seal them with opaque signatures individually. Thus, type abstraction is enforced inside the recursion. Module tree forest. So this declares a tree and this declares a forest. So the tree is a type which is either a leaf or a node of int which contains the forest inside, right? And forest is the list of trees. Okay. So yeah, some example which is similar. Hello, bad cop. Choo choo. Two. Spike is speaking in numbers today. All right, so I'm not sure if this is exactly like my use case, but basically there is a whole PDF about this thing that I'm trying to do here, right? Oh, hello, bad cop. Did you solve the Cinecore? Do you have lists yet? You mean in my programming language? No, not really. I'm trying to like refactor it right now, and the refactor is going to take a while. So I don't know. I think I will try to solving the Cinecore myself a little later. Sounds like a fun thing to try. But I want to like fix my programming language first. So like in order to make progress on my programming language, I need to do a refactoring because of the recursive nature of my programming language, and like OCaml, like it's not a limitation, I guess it's the design, right? But basically in languages like Java or most of programming languages, doing like recursive data structures is really easy, but in OCaml it is not that easy. We need to use recursive modules and we need to copy paste things multiple times, but we can do it, and I have to do it in order to make progress on the language. No fumble, crushed it. Yeah, so maybe in a couple, like I need like probably a couple days to finish this. And this is just some paper I was just looking up if what I'm doing is like really cursed, or is it actually something that people do. So so here's what ChatGPT told me, right? What I'm trying to do. People absolutely do this, mostly in places where joy has already died. So yeah. It is kind of cursed, but it also is kind of like necessary. Here's the simple example. We have two like recursive types. So this is how I was structuring my code previously. We just have two recursive types. Then we define how to like print these types when we define the inference for those, right? Separately. That's how my code is structured right now. And this doesn't really work in case of more complex types. So what we're going to do instead is something like this, where for every type we declare it as a functor which is dependent on the dependencies. So the dependencies are going to be like abstracted away here, which will allow me to not write code all in one file. But it is a lot more verbose than the current way, I guess. Rip joy, yeah. Well, I mean, if you want, we can, before I continue working on this, because that's, I don't know if that's going to be very fun, what I'm doing. I did not solve the second day of the second part of liquidcake's advent of code. I can do that real quick. Wasn't that like Sudoku or something? liquidcake puzzle. This over here. Isn't this basically Sudoku that we need to do? Or like it depends on this thing, on the input, how much how many options we have when like filling in the things. Yeah, sure. Let's do this before we go and suffer. Let's actually solve this. Why not? So this is like liquidcake's advent of code. Part 2. We solved the part 1 the other time. This basically gives you this gives you a map, a 2D map of characters. Every character I don't know if I can explain this really quickly, but if anyone is interested, let's let me just put this link in chat then. So did you do this one? I did do the part 1. That's what I was talking about. Like maybe we should do part 2 before I go into my refactoring. The part 1 was solved though, yeah. So yeah, I was just asking you if part 2 is basically the Sudoku here, but with different rules. So does it like matter in which order we fill in the empty spaces or not? Let's actually see here. So let's actually see. Part 1 and part 2. So over here, right, we have a dot. So this is horizontal, a dot. So this should be a number, which is a cube, right? So what is a cube? Which has 2 digits and starts with a digit 2. There is only a single one, right? So there's only 27. So in this case, it's very easy. Like, but is there any of these places where there are multiple like things that we can fill in? Is my question. So for example, B, right? B is a palindrome. Yeah. So over here, B is a palindrome, right? So in order to fill in this palindrome, because there's obviously like multiple ways to do 2 digits, which are palindromes, any digit will work, which means that we need to fill something else first and then solve this. So this is basically Sudoku, yes. So we need to like find the thing which we can solve for sure, and then try to like fill in something else, right? Yeah, that's it. But it basically means that we just go in a loop, try to see if we can fill in a thing. And then just go in a loop again. Yeah, I guess that's how we do it. Let's go. Source liquidcake. Bum 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 bum. So the first part here Do you went through CS 3110 to learn OCaml? No. No. I just went through the I don't know. I didn't even go through anything. I just tried to write it, I guess. It's a simple language, so like I don't think you need to go through a course. CS 310. OCaml programming, correct, efficient, and beautiful. Oh yes. That's why we love it. Yeah. You always just recreate your past projects in new languages. Yeah, that's what I was doing. Like the only difference between like how I learned OCaml is that I tried to make a programming language, because we heard that OCaml is good for making programming languages, right? But before, when I was trying to learn a new language, I was trying to draw a triangle with OpenGL on the screen, which is how I tried Zig, for example, and like a lot of other languages. And that's why I am making my own programming language, because I tried to make it in OCaml and I realized that I can make a programming language, and it's very fun, I guess, making programming language. So that's why we're doing it. People asked me how I learned Rust. I was like, I don't know. I just started writing it. Yeah. For a long time, the straw that broke the camel's back was multi-core. Did it break something? The multi-core? Multi-core is like the new thing of the OCaml like 5.4, I guess, right? Is that the one where the multi-core was introduced? Like this is where they introduced the effect system or something. Maybe it was even earlier. Is it just OCaml 5? Sorry for the shit joke. No, it just wasn't available for a long time. Oh, the fact that multi-core was not available is why it was... what? Difficult to use the language? OCaml multi-core. Parallel programming in OCaml. So the OCaml was single-threaded before OCaml 5. Yeah, I only started using OCaml like after OCaml 5, because I only use it for a little over a year right now. Getting more traction than it deserved. OCaml was getting more traction than it deserved? Or multi-core made it gain more traction than it deserved? I'm not sure. I don't know the history of OCaml. Okay. Let me try. I want to like write both parts in the single file here. We do have the way to specify that we're solving the part 2 on the command line. It wasn't getting more people interested because of historical lack of multi-core. Yeah. But, like, I mean, isn't JavaScript also, like, basically single-threaded? And people were not stopped because of that, right? So that's not really the reason to not try the language, I think. But the effect system and the way you can do async programming, which is not multi-core but concurrent programming, which is a little bit different, right? If OCaml didn't have that, then maybe writing what I am writing here would be too difficult. I do like having a way to do async. Well, I guess before that there was like the I guess the LWT, which is doing async through the monadic stuff. So we could do something similar, I suppose. Have the actual monads. I have not tried using this, but this sounds like a little bit of a pain. So for example, for the LSP of my programming language, I'm using the EIO backend. But I know that there's LWT too. Like for concurrent stuff. Anyway, we're trying to solve this here. Monads. EIO, like this song. EIO. Yes. How good bad is OCaml in the current environment of language options? Compared to what? I don't know. The worst part about OCaml is its tooling. It's really bad. The LSP constantly crashes, shows me the errors that don't exist and stuff. If you don't like, I mean, I guess you can write code without using the LSP, right? Just like in the old days, and then just like have the compiler show you the errors in a separate terminal, for example. That's something that you could do. If you work like that, then I mean it's a simple language. Simple language can be a good thing and a bad thing. Good thing is that it's easy to learn. Bad thing is that when you're writing a complex program, right, like I am writing, I'm hitting the limitations of what the language can do. Yeah. There are like just the thing that I'm trying to do is a lot easier to do in another language, basically. I keep going back to Rust because it has all the things I want, but maybe there is something I don't know I want. Yeah, if you use Rust, I feel like I like Rust more than OCaml. There are just a couple things in OCaml that are not present in Rust, like the GADTs, for example. But I don't use them a lot, so I'm not sure if that's even needed. There is a thing in Rust which I think is missing, which is the effect system, but that's not present in OCaml either. Yeah. So imagine if in Rust you like one of the things that I want to know, for example, is if the code can panic. There is no way to do that in Rust, right? Because your functions, they can have any side effect, basically. The side effects are you cannot control what can happen. Anything can happen when you call a function, basically, right? So the effect system is a way to have more guarantees about your code. Anyway, let's try writing some code here. The liquidcake part 2. Okay, so what we need to do for this thing is for the part 2, this is going to be a Sudoku solver basically with like the different rules. So we need to first construct the map with the known digits. The known digits, we go over the things. If they are already correct, then we fill them in. That's the thing here. There's Scala if you want to learn functional programming or generic programming or effect systems. Yeah, there is Scala. There's a lot of languages that we can learn from. Wait, Scala. Scala algebraic effects. IOB is just disconnected from Twitch, but I think we're still live. Effects to change control flow with continuations. Yeah, so like they actually have all of this, right? Yeah, I never actually tried Scala. There was some things that I know about it. Yeah, so they use like these contextual arguments as a way of denoting the effects, right? And then yeah. That's almost how I plan to do it in my language too. Raise, nothing. Break, error. What is break? Using label A. Scala util boundary, break, label. What about the continuations? This is just breaking. Delimited continuations. Monads are equivalent to delimited continuations. So direct style effects and monad effects can be seen as just two different syntaxes for writing the same thing. That's true. The implementation is a combination of context, continuations, and type system improvements. I feel like Scala is almost doing this thing exactly as I want. Maybe I should have tried Scala at some point. Is Scala 3 adoption still a disaster? I don't know. They don't show the continuations, though. This is why Scala native is getting continuations. Scala 3 does not yet expose a continuation API. But it has no local exits. So yeah, so you can have effects which basically like are unwinding effects, right? Yeah. Scala 3 continuation API. Is this not exposed still? Do you use Scala 3? I don't use anything, no. I don't use Scala. Scala continuation API. Suspended function and continuations. Most programming in Scala today involves the monadics indirect box styled. Most programmers involves some form of async effects. So future and stuff. Yes. Suspend. Composing suspending functions. Wait, Kotlin also has like suspending? A delay. Pretend we are doing something useful here. Concurrent using async. Async. Lazily started async. I don't think I will be rewriting like the language though. I want to rewrite the language in itself, but continuation folding. Once we have continuation available, we can build structured blocks. Yes. The standard library would include a set of functions related to continuations. There are minimal building blocks from which the other abstractions can be built. If we do it similar way done in Kotlin. Wait, this is just like an imagination how this would work in Scala. Project Loom Java 19 includes support for virtual threads and structured concurrency built on top of continuations. OpenGDK continuation CPP. For me, the beauty of JVM lengths is that you can use Java, Kotlin, Scala Closure together in your stack since they all compile the same bytecode. Well, no, for me this is interesting because of this like because of this feature, I guess, which so like for example in OCaml right now I'm using the effects. In OCaml the effects are completely untyped though, and I guess in Scala you have like these implicit arguments, right, contextual arguments, which basically define what your function can do, and this can like be so like you have more typed effect system, which allows you to catch the bugs at compile time instead of at runtime. More. Anyway. So I'm not doing anything right now. Let's do this. Yes. Okay. So once again, we're doing this puzzle. Part 2 specifically. So we have the letters. For every letter, we like need to go horizontally and vertically wrapping, which introduces like the sequences here. So this means that basically A is these two places, and these two places must be a cube because A is a cube here. That's part of our input, right? So we basically have the set of rules that like these two digits, this number, when we read it, must be a cube. So this must be 27 because 27 is the only cube which starts with the digit 1, right? And then similarly to this, if this over here is B continues forward like this into 2 digits. So these 2 digits must be over here. B is a palindrome. These 2 digits must be a palindrome. So we have like this set of rules like this. Some of these are horizontal horizontal, some of these are vertical, and we have like rules like cube, power of 2, square, multiple of a certain number, right? And we need to basically fill in the empty slots. But before filling the empty slots, we need to fill the non-empty slots, because they are given to us in so we're given like the full map of digits, but we need to only keep those digits which are already passing the rules which are described to us, right? So that's how we get the first digits, and then we need to fill in the remaining ones by satisfying these rules. Hello, Nigel. This is a prologue couple of liner. I don't know what's prologue couple of liner. So yeah, we are going to solve this in my programming language here. We already solved part 1. This, what I described, is part 2. So yeah, we start by figuring out what are these numbers which are correct, right? So we're going to have a new map. We are going to have a new map. You know, like map. We have digit map right now. But this is like the original one. I want to call this like what do I call it? Keeping the digits that are correct. What do I call it? Let's call it Sudoku map. Sudoku map. Yes, because this is basically Sudoku. So I need to basically let's start with a fully empty map here. Map list create for I in 0 to n, for j in 0 to m, row list create, list push back, map row, push back, row none. Row must be mutable. Okay, so this is going to be a list. Let's see, list of optional digit int 32, I guess. No, this is not correct. Type shape as to the option is not equal. Oh yeah, because it's a list of option, right? A 2D map where each cell is an optional int. There we go. So there's our Sudoku map, which is only required for part 2. Okay, so first, when we are checking here, we are going to do the checking. So yeah, we basically say this: if we are doing part 1, then we are adding to the answer if the rule doesn't pass. That was the part 1. But for part 2, what we need to do is, if a rule passes, then we are going to fill in the Sudoku map, right? Oh. If part 1 and not rule passes, then we add to the number there, right? Maybe I return from this function, because we don't have like where this function where this thing is located. So this should return a boolean whether the rule passed or not, right? And so I guess over here I should return false if the This thing is incorrect. This is completely false. Yes, sure. So we check. Or wait, hold on. Or we can have a instead of returning the boolean here. No, let's not do this. Let's not do this. But check is the thing that returns a boolean, right? So check returns bool based on like if the rule passes. But if the rule passes, then I need to write it back, right? So we say if we check this and we are doing part 2, then we're going to write number ij01, right? Which is going to like copy the current number to the Sudoku. So we're going to do the same here. If check and part 2, then we are going to do that. So what is the right number? This is similar to the read number, I guess. Right number. This does not return anything. This does not return anything. And we don't need to calculate the result here at all. We just start at the starting position. We go... I don't need... Yeah, I'm getting like the current digit from the digit map, and I need to just put it into the Sudoku map. And then if the letter, and if we hit the dot, if we hit another letter, then we need to stop. That's all, literally, right? So we just say that Sudoku map list at mut. So we need to Sudoku map at I, and then we need at j. And then we need to assign this to some digit, basically, right? That's all, I think. So we write the number. Okay, yeah, let's do this. And then we say basically, so if part 1, then we just print the answer. But if part 2, then let's just for now see the what we have filled. Right, so we just print the Sudoku map. Print Sudoku map. Okay, what is print Sudoku map? Let's have it here. Print Sudoku map is going to be just a function that does list iterate Sudoku map. So this is row into something. String let line is we just construct the line like this, right? Then we do list iterate row cell into we're going to match cell with, if it's none, then we say line plus equal dot, right? And if it is some x, then we say line plus equal to string x. Is that right? Yeah, cell, this is a reference, right? And then over here we will just print the line. And then we don't type check somewhere. Reference to collections list is not equal to unit. I comment this, then this works, right? How do we run this? Liquidcake part 2, like that. Well, right now I have the syntax error too, right? Skipping expected plus equal. Maybe I need to do this in parentheses. Yeah, I actually need to do this in parentheses. Okay. Hello, elemental magic. Okay. Let's see, part 2. Okay, this is not correct. This is definitely not correct. Oh, wait, I know why it's not correct, though. I know why. It's because over here, we need to use 1, 0. There we go. There you go. So this is the map that we need to solve. Over here, literally the same as we got. Right? Okay. So this is our Sudoku map. Now we need to try to solve it. Okay. Let's see. I guess we just do something simple, as in Merry Christmas. Merry Christmas. Merry Christmas. It hasn't happened to you yet. Well, we don't really celebrate Christmas here. We celebrate New Year instead. But yeah. Merry Christmas. While is Sudoku, while not is Sudoku solved, we just do something, right? So is Sudoku solved similarly to print Sudoku map? I guess. Let's do this. Print like is Sudoku solved? It's going to be like that needs to return boolean with return. I guess I can do like that. So we just return false. Yeah, we just return true here, right? But if we go over the cell and the cell is none, in this case we just return false. Right? But that's all, right? That's all that I need to do. So while Sudoku is not solved, let's see here. Print solving, like trying to fill in more digits, something like that. Right, so right now I'm not really like trying to feel anything. So how do we try to feel something? We just go over the things, right? Try fill more. Try to fill digits. Let's just do that. Okay. Try fill digits. I guess I just need to go over very similarly to how I was doing it here, and we basically, please rewrite your code in Haskell. Which one? This one? No, this is me testing my own programming language. That's the whole purpose of it. So that you can write a white paper about it. Yeah. Rewriting the programming language in Haskell is something that probably also won't happen because I don't want to rewrite it anymore. Please rewrite your code in kast. Yes, that's the goal. This code is already kast though, so there is nothing to rewrite here. Rewrite kast in kast. Yes, that's the goal. I'm going to try to rewrite kast in kast next year at some point, as soon as possible. That's the goal. I just need to fix a couple things before doing that and implement the like transpiler. OCaml to Haskell is the natural progression. Well, I heard some OCaml programmers which hate Haskell. I don't really know the reason, but they think that OCaml is a better language than Haskell. Let's see why, though. I don't really understand their points. Like I think that Haskell is in theory a better language. In practice, Rust is better than both of OCaml and Haskell, I guess. But in theory, Haskell is better. Why is OCaml better than Haskell? Compile time is about to be 30 hours. Predictable performance. Why is this lazy moment? Eager evaluation is better than lazy evaluation. Simple runtime model. Modules that don't hate you. Well, my modules actually hate me. OCaml's module system is powerful and understandable. Haskell types classes start elegant and end up like Rube Goldberg machine made of abstractions. I don't know about that. Better tooling experience. Well, I mean, okay, yeah, if that is true, OCaml's tooling sucks, but compared to Haskell, it is like really good, I guess. But yeah. Ask it if Bash would be better. Bash Cop is asking whether Bash would be better. Bash is barely a language. It's a historical accident that escaped containment. Here's the blunt reality. Bash has no types. Syntax is hostile. Refactoring is pain. Performance is terrible. Errors are optional. Bash getting bashed. Well, Batcop asked for it. The opposite is true. OCaml modules are harder to maintain because they try to be more powerful than vanilla Haskell type classes without multi-parameters. Well, it's because you are the you like Haskell, but there are people who like OCaml more for some reason. Well, I mean, there are reasons, right? Like the reason I'm not writing Rust and writing OCaml because of compile times. So OCaml is a simpler language; it compiles really fast, and and Haskell is. I don't have like a lot of practical experience with Haskell, but from what I understand, the compile times are even worse there. Why is my ChatGPT so mean? I don't know. I don't know. Okay, try fill digits, right? So we just go over the thing. And we like try fill this thing. Try fill IG01. Yeah, I guess we can just do try fill C IJ01. We don't do part 2 here. Capital C. And then we like try fill capital C IJ10. Like so, right? Try fill. Okay, try feel is trying to feel like a single thing, which feels the character, starting position, and direction. Okay, how do we write this? How do we write this? So first I need to like read. It's similar to like reading the number, I guess. But I'm going to read the number with like optional digits or something. Right? Right number. Dun, dun. This should be called like a right number from digit map. Right number from digit map. So I want to say have something similar to reading the number from digit map, but I need to read number from Sudoku map. This is not going to return the integer, because this just must be a list of integers, and this is not optional, right? So this should just return me a list of optional integer, I think, right? So every digit is an element in this list, and it's not necessarily present, right? So result is list create. We return result. Digit is this. We have a Sudoku map here. Digit. So this digit is an optional int, and we just say list push back result digit. Okay, can we like unify this without copy pasta? Okay, so when we try fill here, I need to like read the number, right? So number is read number from Sudoku map. SI, SJ, DI, DJ. Okay, so this is a list. So we know how many digits we have. We know which digits are filled, which digits are not. And what do we do? Can we, so like, we need to like basically figure out all of the different things that we can put there, right? I guess it depends on the rule here, right? I guess it depends on the rule. So for example, yeah, I guess it depends on the rule. Check, right? Yeah, let's get the rule here. So rule is the letter rule. We're going to match rule with... When are you adding hieroglyphs to your language? Why would I add hieroglyphs to my language? Let's try with the simple ones. For example, if we need the palindrome, then what do we do here? generics. Generics, we already have generics. You can see me using them here already. Like, for example, a map or an option is a generic type. If we have palindrome, then what we need to say is like, in order to be able to fill in a palindrome, we need to have no like no place which is mirrored both empty, right? Yeah, that's it. So we need to go for I in 0 to list length of a number divided by 2, I think, right? Divided by 2, like, but rounded up, I think, is what we need, right? Because in case it's an odd length, we need to still check the middle one. Yeah. So I need to, yeah, let's say that new number, this is going to be, so instead of a list of option integers, we have an option of a list of integers, which is the digits, right? That's what we want to get here. We're going to say let mut result is list. Do I have list map? I don't have list maps, right? Hello, Nerdzel. Let's create for underscore in 0 to list length number. I mean, I think I can just do the new number like this, new number. Well, I mean, I guess field. I'm just going to initialize it with all zeros or like -1s or whatever. List pushback field -1. Let's start with that. So new number, this is going to be called field. So I'm going to return some field here, right? But like we just go over here. We say that let A be equal to list at, so like the number at index I, right? Let's say index j is length of number minus I minus 1, right? So like the opposite one. So we do this, and we say b is this at j, right? So now we need to match a and b, right, with if we have none and none, which means that they are both not filled. In this case, we actually we cannot know what we cannot fill anything, right? Because there are multiple options of what we can fill. But if we have some x and none, then we okay, so this is like digit d, right? Then we return, let's not call it d, let's call it digit. So we have some digit in one and digit and none in the other, we return digit. If we have none and some digit, then we return digit. if we have some digit A and some digit B, we just need to assert basically that they are the same, right? So if digit A is not equal to digit B, then panic. Palindrome invalid. And we return digit A. So this is the digit that we need to fill in both of the places, right? So we say that list at the field one at index I is equal to the digit, and at J is also equal to digit at mut. Okay. All right. So this is how we fill the palindrome. Let's say that if we have anything else, then we're just going to return none. So we cannot fill anything. Try fill probably should return boolean whether I have actually filled or not. Anything. So whether I made progress or not, basically, is what I do want to return here. So we are now going to match field with none, then we return false. And if we have some, then I'm going to write it to the Sudoku map and I'm going to return true. Right? Why are the type constructors prefixed with a colon? Because of the syntax ambiguity in the other in other cases. So the languages like OCaml, they solve it by having your type constructors always uppercase and like variables always lowercase. I don't have like this distinction based on the like capitalization of the first letter. So we need to have some other distinction, which is why we are prefixing it with a colon right now. I'm not even sure if I can like do it based on capitalization really. Like we have like also types being treated as values. We probably want the types to be like capitalized to distinguish them from values, like but we cannot really enforce it because types are values. So you know, I don't think capitalization works for me. This is the same kind of like in, so we kind of could do it like this with like, and then like detect it based on like the type inference. This is what Rust does, but it means that this can sometimes mean match anything and assign it to a variable named sum, and sometimes it can mean pattern match the type constructor named sum, which is different semantics, right? So that's why I don't like how it works in Rust, right? Let me show you it again. Here in Rust, you can write code like this. You can match like, for example, you can match some x, some 1 to 3, and you can match like none, then you say like whatever, right? Let me remember how to write Rust. And you have like some, or let's not do none, right? Let's match it with like some underscore, then we don't do anything. And if we like, let's just say that we over here, we do a typo, right? So here's the thing. This still compiles. This looks like this is a variant name, right? But it instead matches everything, and it introduces this as the variable named none. And I think this is wrong, which is why I instead prefix this. There is a warning that Rust shows you. But like, how do you even know that when you say none, that this is a variant, or if this is a new variable, right? That's the question. So it really depends on the definition of the type here. So you cannot know if this is a variable or a variant name just looking at the syntax. You know, you need to understand like what the type is and whether this is a valid constructor there. Which is, I don't really like that. Even although there is a warning. I don't really like the way that I'm prefacing with colons. It maybe is a little ugly, but I'm kind of used to it. It's not too bad. Can feel like it's unneeded though, right? Also, maybe we should replace the colon with some other symbol, but I don't know what to replace it with. If you have ideas, let me know. But that's the reason why they are there. Okay, so if they are filled, then I need to... yeah, we're using a dot at one point in time, so that's what Zig does, for example, right? When you have the enums, you can match on like dot num and dot sum. The reason I don't do that is because we have another feature, which is like we have tuples with named arguments, with named fields, right? Well, which is in general how you do like structs. So I can just say like x is equal to 1 to 3. And if we say like x is equal to x, then similar to Rust, we can short, we have the shorthand syntax, which is .x. And now there is also the new ambiguity. Is this x the variant, or is it me trying to initialize like the struct of this thing, which is different? Why not take inspiration from OCaml? Use this because it's named, or you mean like, or you want me to use named here? I don't know. I feel like dot makes sense for using fields. So like this is not really a field because, right, this is a variant of this type, which is why I think having this not as a dot but as a different symbol makes more sense to me. Because dots are used for fields in all of the places, including OCaml. But variant names, they are not fields. So maybe like using dots for those makes a little less sense. All right. Anyway, so I'm trying to fill this here. What's the problem? Boolean is not unit. Yeah, I need to like, this is what I return here. And over here, some fields, right? I'm going to maintain my own fork of kast with the tilde for named field. Okay. Let's just do here fill si sj di dj field, right? That's what we want, and we return true. So what is fill? Try fill, and then fill. Fill has the number, which is a list of digits, right? So this is similar to this right number from Sudoku map, I guess. Wait, this was a reading, but anyway, yeah, I think what we do is just something like this. We do list iterate number, and then we have the digit, and then we need to write it there, right? So we say that list at mod we need to have the Sudoku map at I and then at j, and then we need to like assign this to some digit, right? And then after that we move to the next thing, and that's all I think that I need to do here. This does not return a boolean. Okay, so yeah, try field returns a boolean. Try field here So try field digits. This also returns a boolean whether we actually filled something or not. Let's move made progress is false, right? Over here we say if we did this, then made progress is true. And similarly over here, we return made progress in the end. 1 0 capital C, like this. So we try field digits. And if try filling digits did not succeed, right? Did not succeed, then we, in this case, we need to like panic. We need to like panic. Could not make progress. One second. Could not make progress. Remember that from parser source code. Yeah. Okay, could not make progress. We are going to actually have this where that we could not make progress, right? Because... Wait. Oh, wait. No. Wait, I have filled a single digit already, right? 43. Why? Let's see why. Like, is that correct or is that not correct? This is correct number, and the reason is because C... Probably C. C is a palindrome. Capital C is a palindrome. So C... So this over here is 33. This is a palindrome, and so we can fill this number because we know that this is a 3 already originally. So we are filling this 3 because we're only filling the palindromes right now. That actually that means that we just need to fill the remaining ones. But it is still looping infinitely because I am still thinking that I'm making progress if I fill the already fully filled thing, right? So I need to read the number. And then to like list iterate, let already filled is true. If already filled, then we just return false, I guess. So this is also with return or whatever. So we just iterate number, digit, match, hello Davinia. We say that, we say over here that if digit is none. No, if digit is none, then we return false. Like this. So this return corresponds to this block. Can I remove this? I guess I can. Okay, there you go. So here's our current progress. We start with this, then we try to fill digits. We know that this is a palindrome. We fill the 3. And that's all. Okay, so now we just need to fill in the other rules, right? So what are the other rules? If I remove this is going to say that pattern match was not exhaustive, but it's not telling me what is the variant that we had there, right? Yeah, how about we do this? Maybe I need to like dbg print rule. Yeah, I think we just dbg print rule here. We return none. Yeah, so there you go. We have 2 power of 3. All right. Well, let's start with that. 2 power of. Power. I mean, I can just fill all of this, right? Multiple of mult. We just are going to fill this in, right? To do. And what else is there? Just power of. Power of base. Yeah, that's all. So this should be exhaustive pattern matching now. All right. Power of base. This one should be like pretty easy, I think. Right? Power of base. Do you intend to add the OCaml syntax sugar for function definitions? Let foo x is y. Potentially. Maybe. You don't like it personally? Yeah, I'm not sure if I like it either. But there, like I don't feel like I need it. It makes the names hard to catch at a glance. Because they blend in with the argument names. Yeah, I don't know. But there are some interesting things about this. There's a thing that's called like a copattern, I guess, which is a more generic way of like doing that, I guess, right? So you can you define the function definition by saying how to use it. So you declare how to use the function, right? So you use the function by calling fx, right? So the result of fx is this, right? So over here, what can we use here? What if we could use any expression here, right? So for example, you say f dot x is equal to this, which means that f is like a struct where field x is equal to this, right? So you know, what are the other things that can potentially be used here? And then you can like combine all of these equalities into the thing. I'm not sure though if I'm going to go this route. But basically, what can be on the left side of the assignment, right? And right now, function application, which is how you would define a function, is not possible. But I don't know. I haven't thought about it too much. But there is potentially some like it removes some of the repetition, right? We don't really like to repeat ourselves, right? So you have a function f which takes like an option, right? Option is option int, right? And then you need to like match option with like some x, then you do one thing, and then if you match with none, then you do the other thing, right? You see how much code there is here? But what you could do is you can say just like f some x is like a, and then f none is b, right? Which is kind of a lot shorter because you don't really give the name to this argument and then do the pattern matching, right? In OCaml you can just there is a shorthand syntax which is called function, but in case of like nested arguments you cannot really do this, It looks handy, but it's not obvious to me that there is no other better way to compress that. Yeah, maybe. Maybe. So far I don't really plan to do this, but yeah, like reducing the repetition is a nice thing. Potentially. Elixir written. Okay, let's see here. So when we have the power of base, we just need to say lat mut x is equal to 1. I need to like figure out the minimum and the maximum number, I think, based on the number length. Yeah, how about we do that here? Let's see. Minimum and maximum is right. So minimum is going to be basically 10 to the power of least length minus 1, right? Minimum is 1 or 0, or I guess 1, just 1 to list length of number. We say minimum times equal 10. Right, and what's the maximum? The maximum is where everything is just 999. Right, so maximum is just minimum times 10 minus 1, I guess. Yeah, sure, well, let's do that. So when we say the power of, we need to say basically while x is less than minimum, then we say x times equal base, right? And then we say while x is less than maximum, less than or equal than maximum, then we do something, and then we say x times equal base again, right? And over here we need to like basically try this thing, right? So we should try x. Yeah, I want something like this. Yeah. What does try mean? Try means that we have like options. I feel like this match rule with we're going to match it again here. Like this. Yeah, so we have like field is none. I will return the field here. When we say try is basically try is having x, which is an integer. We basically so we need to like check it against the current pattern, right? Yeah, we need to check it against the current pattern. List iterate number digit what's wrong right now? LSP start. My LSP just crashed. Maybe it used too much RAM. We have digit. Yeah, and we need to like figure out the digit of x. Well, we go the digits from the most significant here. I need to like iterate in reverse here. Do you have a special place expression for the referenced fields? And is it just tuple field, or does it have special syntax? Tuple.field, right? We have an object. Well, I mean, we have object.field, right? This is a place expression. Place expression automatically dereferences it unless you take the reference from it, just like in Rust. If object itself is a reference, then we do explicit dereference because we don't have the automatic dereferencing right now like Rust. So that's how you do it, I guess. If object itself is a reference. I don't think we need this arrow like in C. I think we will actually perform the automatic dereferencing like Rust instead. So it will still be just tuple.field. Just not yet. Okay, so we iterate here. Wait, I have the LSP working, but the syntax highlighting is gone. Is it the syntax? Wait, hold on. The syntax highlighting is gone after a certain point. Only in this function also, which is very weird. That's weird. Every other feature of the LSP is working. Okay, so check. I need to like say that like the like acts as list, you know, as list is list create. Let's just convert this number to a list now, right? I cannot do a reverse of the list. Can I have? Do I have iter_rev? No, I don't have iter_rev. I can iterate in reverse though. In general, like later. Let as list is. Let mut list is list create while x is not equal to 0, I guess, right? We say list push back list x mod 10 and then x divide by 10, but then I need to reverse it. How do you reverse a list? We can create a new list, but let's call this reversed. For I in 0 to list length reversed dot rev. Do we have that working? Dot rev. That was there in day 10. I guess I can implement this in that as a local syntax too. Sure. So now this is working properly. Let mut list is list create. We will return the list. And over here, list push back list list at reversed I dereferenced, I guess. Object field would first copy object to the stack and then offset to field. But object field would make it so that field is copied to the stack. Well, in C, yes, I guess, but not in my language, because object dereferenced is not having like copying the thing onto the stack, because object dereferencing is still a place expression. So for example, when you say like a reference to object dereferenced, right, this does not copy the object to the stack, and it does not do this in Rust either. When you I think I'm pretty sure it doesn't do that in C either, though. This over here is a place expression. When you take a reference to the place, you don't need to know the value that is stored in the place. Okay, so this is as list. Okay, let's say that if as list, if list length as list is not equal to list length number, then let's just panic here. Panic different length, like it should not, because we should only try the numbers of the correct length, because it's between the minimum and the maximum, I guess, right? Well, I guess we can also say that if x is less than minimum or x is more than maximum, then panic out of range, out of acceptable range. Okay, and now we just need to like match that the digits that are already filled in match the digits that we have in this number, right? So we just say that we just do for I in 0 to list length number. In C, the reference just converts it into an L value. Yes, that's what we are talking about. L values, we call these place expressions. Instead of saying that it's an L value, we use the that's the same as Rust. Rust also uses the place instead of L value naming. But places are basically L values. That's all they are. Okay, so yeah, so we just say that try with return, I guess. Let's see. Yeah, so we are going to match list at number I or I guess not match. We just do if this is some expected, right? So we have an expected digit and like the actual digit. So actual digit is list at as list I, right? So if expected is not equal to actual, then we just return. Right? Did you add if val is variant to the std lib? No. This is defined in this. We have these three syntaxes: the is, and this is just desugaring to the match, right? And the for range in reverse is also the special syntax here for now. And an L value is basically just a pointer. Yes, an L value is just a pointer, which is implicitly the reference unless you escape the deref with the reference, or unless you like convert it to like or like to a different L value, for example, by getting a field out of it, right? That it converts to a different L value. Yes. Yeah, we literally have the same semantics here. So now we have checked that we match, and now since we match, we just say that a field is sum as list. But if we already have, if field is sum, right? Then is sum another, right? Then it means that we have two different options. We have two different options of what this can be. L values are super convenient, but it is annoying how they tend to lead to extra syntax. Yeah, I don't know. Yeah, I don't know. Is it annoying? I mean, you have extra syntax, but I mean, in a language without L values, like OCaml, for example, you have you still have like, I guess it's not extra syntax then, but well, I mean, it is extra syntax, right? In OCaml, you still have references, but you like explicitly create them only in some places. Then I don't know. I feel like it's more annoying. The way you do it in OCaml. You don't really need it only in a language which is like purely functional without mutation, but even in Haskell, you still like need to do that sometimes. Like the only reason you need the references is because you want to have mutations, right? If you don't have mutation, you don't need the references, I guess, at all. But in Haskell, you create like IORef or STRef or something, which I think is leading to it being even more annoying when you need it, right? And it is important to have mutation for performance. It filled some another over here. Not panic. Not panic. I'm just saying that I have already like multiple that not like I think more about normal pointers versus references rather than mutable versus immutable. Well, yeah, but what is the reason to have references in your language at all if you don't have mutation? Because you can have all of the things being passed by reference automatically if your language is immutable. Because like, since you cannot mutate, copying the value and passing it by reference is the same thing, right? I don't know what to call this. But over here, I just want to unwind go with none, I guess. What should this be called? Feeling, whatever. Not very familiar with immutable languages, so when I talk about languages, I'm not normally thinking about what that is work with strictly immutability. Immutability is interesting. There's not a lot of languages that are like fully immutable. Like I think like isn't Haskell like basically kind of the only one? I mean there are others like I don't know. I guess like something like Idris also doesn't have mutability, right? Elm, PureScript, Idris. Right. This is the list. Okay, so we do that. So if we have like at least 2 options, then it means that we cannot feel anything. So we unwind there. We could extract this into a function, I guess, or whatever. Yeah, we just... Okay, so the power of is, I think, just done, right? And over here, we just return the field. Like that. Yep. Let's see if I feel anything. Not really. No, not mutable. Something is not mutable at line 362. X. Yes, X is not mutable. Try X. I guess I can, like, say here, let's move X as X. Type inference error at line 385. Match rule. Wait, what is rule? Oh, rule is sum. Wait, no, rule is the letter rule. That's right. Oh, what do we return here? I guess we don't return anything, right? We just do this. It's the branches have the different things. Okay, it seems like I did not... Wait, hold on. What is that? I just replaced a 3 with a 2? That makes no sense. I've been thinking recently about how systems language tend to be less generic because they are pinned to operating system APIs and server formats. Makes me think what other avenues might be more promising to take advantage of functional programming at that level. Well, I want to have, yes, I do want to not lock myself to the operating system APIs indeed. Bad mic? Wait, what really? Kast LSP? What exactly is bad? The same as it was before. Compile mic. I'm using the new microphone, so it's so my old microphone was still working properly, and I just got the new microphone for no reason then. It's good now. Yeah, but it's the same as was happening before with my old microphone, right? I thought it stopped happening once I got this one. Alright, well, it is a software issue then, I guess. NixOS problem then. Okay, why did I do this? Why did I do this? How about over here? I say... fill. How about I do here dbg print rule si sj di dj filled I'm just going to convert this into an integer, right? Let mode x is 0. List iterate filled digit x is x times 10 plus digit x. Just so that we debug this here. What did I actually print, right? So we are saying that palindrome at 1110 is 33, and then we are saying that at 1101 is 32. Wait, 1101 is 32. Wait, it wrote it into the wrong place. The thing, right? Yeah. I think it is correct. Here's our puzzle. Yeah, this over here, we need this to be 32 because this is a power of 2, right? This C is a power of 2. We know that this is a 3 because this is a palindrome, so we can fill this with a 32 because 32 is a power of 2. We are doing it correctly, we're just not filling the number correctly. For some reason. So try fill. Oh, I say di. Look at this. Di. Dij. That's a typo. There you go. So now we have filled another digit. What's the evaluation order in your tuples, by the way? I think it's actually not specified right now. We need to fix it probably. I'm not sure. I think I do have an evaluation order. No, I think it's in the order of definition. Yes. But we need to like confirm that it is because it should be. Like I do store the order in my tuples. Something that feels obvious is a language where all non-recursive procedures are suspendable. So you can call them normally, or do something like core new core run co. Why is that obvious? And also, why are you limiting yourself to non-recursive procedures? Since you're using the core new, I guess you are a C++ developer mainly. I did not use the coroutines in C++. Suspendable is I don't think it should be implicit. Like, when do you suspend? Because recursion is the only thing that makes the stack space unbounded. Yes, but I guess like it depends on your implementation of the coroutines. You have basically two ways, right? So in C++ and in Rust, I guess, you need to like break the recursion by introducing the like the indirection. So in Rust, you would like just box one of the the coroutine that you are running. Yeah, but you mean stackless coroutines, but you can do stackful coroutines too, right? And then you can do it with recursion. I think I will do stackful coroutines in my language, but I need to like look more into like, are the stackless actually needed? I don't think it requires a GC. The only thing that is required is that when you switch to a different coroutine, you need to like basically switch your stack, right? So your stack is going to live on the heap. That's the only thing. It does not require a GC, but it does require like, I guess, a runtime a little bit, where your stack is not like the C call stack, but your stack lives on the heap. So that you can switch between multiple stacks, basically. That's normally called a fiber, I think. Right? Fibers. Do you have fibers in C++? Lightweight thread of execution. So when you switch the context, you need to like switch your current stack basically also, right? We can regard fiber as a form of stackful coroutine, which is not available in C++. So that's how it is implemented under the hood in Camel. I'm just like wondering, what is the downside of this? What is the downside of this? I'm not really sure if there is a downside. A low-level language where allocating every procedure on the heap isn't really acceptable. Well, you're not going to allocate on everywhere. You're only allocating when you so like the way I'm planning to do this, you basically have like the explicit places where you generate a new stack, basically, I guess. But I mean, yeah, I can. Yeah, I guess that will require the allocation, though. Indeed. Yeah, I'll need to like think about it more. Can you really not do stackful without? They might not even require language support if you're making something low level. Yeah, but I do want to have like the language feature, which allows me to implement that. I want specifically what I want is I want delimited continuations. Stackless. Sorry. Okay. Fibers, coroutines versus delimited continuations. Stackful coroutines is equivalent to one-shot delimited continuation. Stack. This seems like a nice one, maybe. Continuation, delimited or unlimited, stackful or stackless. I do want delimited ones. Generators as implemented in JavaScript have another crucial restriction which does not exist in shift reset based generator above. JavaScript's yield analogously to return from other function can only be called inside the top level of the generator body. Okay, I'm not going to look into this right now, though. And first class suspension. Yeah, we do want to have first class suspension. I guess like the easier way of implementing it is by having stack full stuff. But if we want to have the language that is low level, then we need to make sure that the allocation that it's possible to do it without allocation, which might require just stackless, right? I need to like look more into that a little bit. Yeah, that's an important feature for me. I don't really use it yet in this right? But for example, what I don't have, as you can see, when I'm iterating over like the input, for example, right? I do string lines. So this is basically instead of saying for line in string lines of input, right? Because I don't have the iterators yet. What I want this to be implemented as is that this lines is going to be basically the suspendable like function with yielding functionality, right? So we would just yield lines there. So this is the going to be the function with the yielding effect, which will need to be suspended basically. Yep. Stackable coroutines will probably should always be keep allocated. Allocating large charges for like stacks in stacks isn't very safe. Yeah, I'm just like if the allocation is only happening once, right, like in the beginning of the program, then it's probably fine, right? Yeah. Dynamically growing this stack is... I'm not sure if that's needed, really. Anyway, let me see. We need to implement multiple of. Okay, so multiple of... We have this, so we have the minimum, right? We need to find the minimum number, x, such that x times mult is more than or equal than minimum, right? How do we find this? How do we find the minimum x? So it basically means that x is more than or equal than minimum divided by mult, right? So we need to divide this and round up, right? So we say that x is minimum plus mult minus 1 divided by mult. That's how you divide a rounding up, right? And then we say that while x is less than or equal than maximum, we just say that x plus equal mult, I guess, right? And then we just try x. Okay, and to the power of is so this is basically yeah. Let's see. Let mod x is let's see. Let pow is x into result is 1 for underscore in 0 to power a result times equal x result, right? So we say that x is equal to 1, and then we do while x is less than minimum, while the power of x is less than minimum, do x plus equal 1. So this is maybe slow, but this is basically me taking the root. If power is 2, then it's like the square root of the number. Could be a constant time operation, but I think this should be quick enough. And then we say while power of x I guess let's just do loop here. Let p is power x. If p is more than maximum, then break x plus equal 1. And then we try p here, right? I think that's all. Out of acceptable range. Oh, wait, which one? Out of acceptable range? Which one? Which one? Try out of acceptable range. dbg print rule x min max. Multiple of 3099 and I try 1. Okay, why do I try 1? Because we have multiple of. I guess this over here is not correct. Right? So we have a minimum which is 1000. I need to divide this by oh wait. Yeah, I need to like multiply this by multiplier back, right? That's what I need to do. Times again. We like divide and then we multiply back and that's how we get 1000 back, right? Okay. Wait, okay. I think I have solved this thing properly now. dbg print over here. This can be commented out, I suppose. Okay, but so we basically just do 2 print Sudoku map in the end. Let's see if this is solved properly. Puzzle 27994326 13975275. Okay, and then we just do this on the actual input. Could not make progress. Wait, so I cannot do this on the actual one. Oh no, are you saying that we actually need to like brute force this? So this is a Sudoku where we cannot like, oh my god. No, this is an actual Sudoku. So you can, there is not always like a thing that we can try. So we need to brute force. We have multiple like single steps that we can do. So we need to like try some of them. Oh no. 4x4 grid is the sample, and this is the actual input. Or just like in Advent of Code, you have the examples and the actual inputs. Yeah. Okay, so we have the actual Sudoku here. I did feel some things. But now we have like multiple options. We need to be doing the attempting of doing something. So how do you do this? How do you do this Sudoku solver? Like we need to like recursively try things. So try fill digits is trying to feel So if we cannot make progress, then it means that every time, like, so over here I'm trying a specific thing, right? And when I try the specific number, I need to like actually like try if I can solve if I feel it with this number. Alme Grante, oh camel. Yeah, I'm not writing camel right now. This is my programming language, but we're going to back into... I'm not sure if I'm going to go back into OCaml actually today because I've been solving this advent of code instead. Yeah, I'm working on my language, which is written in OCaml. There was a huge refactoring that I'm trying to do, so yeah. I guess we delay it until next time. So let's at least solve this thing. So we are doing something similar to Sudoku. Solver. So we need to do this recursively, right? When I try this, yeah. So we have like, okay. So we have like panic, palindrome invalid. Already filled. Read the number from Sudoku map. I just like check that it's currently correct, right? Do I just literally do brute force? Well, I mean, not exactly brute force, right? Like, we need to... So, try feel is going to, like, recursively try... to do the things. So, we have this Sudoku... Okay. Hold on. Is Sudoku solved? Let's have this take Sudoku... map as the argument. How about that? How about that? Is Sudoku solved? Sudoku map. And then we print Sudoku map. Is going to be printing Sudoku map. Sudoku map. Sudoku map. Sudoku map. Right? I mean, that's the same thing. But we are going to try few digits in the Sudoku map. I'm just trying to, like, I guess I don't really mutate Sudoku map, right? I give it the reference to Sudoku map. Try few digits. This has a reference to Sudoku map. So over here we try to fill the Sudoku map. Actually, you know what? I mean, fine, whatever. We pass it as an argument. Okay, Sudoku map. Sudoku map. This means that try fill has a Sudoku map. Read from Sudoku map, Sudoku map. Read from Sudoku map has Sudoku map as the argument. Right? Okay, and then feel. So feel, right? Feel is when we actually like mutate the Sudoku map. But this is going to instead say Sudoku map. Sudoku map. So we are going to construct, when filling, we are going to construct a new Sudoku map, which is equal to the copy of this, with these things filled, and then we are going to try to perform more progress there, right? Yeah. That makes sense. Yeah, so we need to first copy let mut Sudoku map is clone this. I don't have the cloning of the lists, so we just say let mut like clone is list create list iterate Sudoku map row into at mut clone row is list create, and then we'll list iterate row cell. We just say list pushback clone row cell. I guess cell, we need to dereference it, and then we say list push back clone row, and then we return the clone here, right? So we clone the Sudoku map. Then we fill this number in, and then after that, I need to like recursively try and call the thing, right? Recursively try to make progress, right? Yeah, this one should be done recursively. So in order to do it recursively, right, try fill digits. This is try make progress. Try make progress on this new Sudoku map, right? This right now is not found because I'm not in a recursive scope. So we need to say that I don't know. Let's say part 2 is this over here, this module, I guess, right? So we just say part 2. Ah, shit. What did I open? Help. Part 2, try fill digits. Like this. Fill. Filled. So fill should also fill Sudoku map as the argument. Try fill. Reference. Sudoku map. This is a list. This should be a reference to the list though, right? Sudoku map list. Yeah. Row. Wait, what's the problem here? Because Sudoku map. Oh, this Sudoku map, this should be a reference. Okay, let's say this is a reference to Sudoku map. Let's just annotate our types here. Sudoku map, reference to Sudoku map. But I mean, Sudoku map is just... this is what it is, right? Sudoku map is just this type. Wait, is my line 302. Why was the sysadmin unable to play Sudoku? It's because they were running OpenBSD and had to play do ASCII. Is that a dead joke or something? Oh yeah, this is a reference. There we go. That's the problem. It seems like my LSP right now is broken. Let's there we go. I guess we need to quit and open it again. Okay, now it feels like it's working. But yeah, we basically, you know, we just basically try fill digits. This means basically try solve, right? We are trying to solve the Sudoku. So we don't say while not is Sudoku solved. Try fill. This is trying to fill in a specific position. I guess we don't return true or false, or I don't know. Should this maybe this should this should so I don't really return true anymore, right? We're trying to do this. We don't even return anything here, right? We don't return anything here. We don't return true, we don't return false. If field is some field, so try field does not return a bool. We just say try field is right. And we just try fill that. So we try starting in all of the different places too, right? Okay, so we just say, we just basically say try, so okay, we just say part2 dot try solve Sudoku map, right? So what is the result of this? This should not return boolean. This should return the solved Sudoku map, right? So optional Sudoku map, right? That's what we're doing. Or maybe we don't even return anything here. Made progress. We just try solve this. Right. And then we want to have yeah, let's just do unwindable solving that, right? Let solved is this. Panic could not solve. I think something like this is what we want. So we want to make sure with current solvable solving, and then we just print the solved. So what is current solvable? Part 2 current solvable. Current solvable. Context. A Sudoku map, I guess. No, not Sudoku map. Wait. What do we have? How do I write that? Rules. Unwind. No. stdlib. Unwind unit. Context. Oh, yeah, this is unwind unit. And like unwindable block with a specific result, right? Well, I mean, it is just context, maybe. Let's see what happens here. Line 300. So this is not inferred, right? The way we infer this is we try use the context. I guess I cannot like write it out explicitly right now, but we basically say that when we try solve, if this is already solved, right? So if is Sudoku solved, Sudoku map, then we just well, I guess we just do this. Maybe. So we just say current solvable, and then we like unwind this with the current Sudoku map. Is that what I do? 362. 462. Wait, this is still okay. I need to actually infer this at compile time. Should I? Maybe not. 326 already filled. Yeah, wait, hold on, what? This over here is wrong. Already filled, just return. Assign 326. This does not work. Why? Boolean is not unit. Oh, wait, this should be false, that's right. Because I'm returning from this block, not from the function here. That makes sense. 462. This is still not awaitable, okay. So I cannot do that right now. Current solvable. Let's have a context where we have the you know, found solution is a function which takes Sudoku map and returns like unit, for example. Like that's what we want. Current context type. That's what we do here, right? That is going to be, so we just do, okay, so we just do current solvable found solution Sudoku map dereferenced, right? Like that. That's what we want. So then we say that with current solvable is when we found solution, then we unwind Solving with a solution. Right? That's what we want. Okay, well, something is happening now. But what is happening, right? I need to, like, print my my things. What am I trying, right? Print, trying to solve, print Sudoku map. Well, I mean, it is doing something. Yeah, it is indeed. So this is the brute forcing. It's just we're trying the same things again and again, right? Do we need to, like, cache? Wait, but why am I trying the same thing again and again, right? That is the question. Well, now it's a little different. I feel like I just need to not try anything if I have already seen this. But the question is, how do we how do we know that if we've already seen this? I need to put this into like a map or something. Have I seen this state before or not, right? Have I seen this state before or not? So yeah, I do have a map, right? Okay, let's do this. Let's do this then. We have visited states. It's just like I don't have set, right? But we have map. Yeah, I mean, literally, I need to see if I seen this before or not, right? So what I need is so if it is already solved, then we found the solution. But if I did not already solve it, but I have seen this, I have visited this, right? If is visited, if visited is just map. Well, let's see what we have there. We have get, which returns an option, right? That's what we need. So if map get Sudoku map, so we're not mutating it, and we can just have this as a key then, right? The Sudoku map. A map get visited states Sudoku map option is some then well, I mean, I guess what we do is we do map get or init, right? Visited states Sudoku map, and then the way we initialize this is we just return unit here, but we say need to solve I don't know, visited is false over here. Visited is true, right? So we are automatically inserted there too. So now if visited, then we just return. This is compiling because I'm not checking that we implement the things. Wait, could not solve. Oh wait, no. Visited is true, but if it's not visited, then visited is false. That's what we want. Right? There we go. This is not going to work though properly, because we're still doing the same states, because the comparison operator right now is not the correct one. But I cannot, wait, hold on, I cannot do the comparison operator because I'm not doing it through the traits right now, right? I can implement this with the trips though, properly. How about this then? How about this? We will create the new visited map. Visited, you know, something, something. Can you write a compiler in Python? You can, yes. Why not? You can write it in any language. So we will store a trip. So it's a trip of references to Sudoku maps, I guess. Why not? Since they are immutable, we can just store the references there. And I need to do that then. Write a compiler in SQL, please. I mean, I think technically it's possible. You write the the SQL thing, which I mean, I think it should be possible. Why not? I'm not going to do that though, and because I'm not trying to suffer, but should be doable. Create is function which just returns inner is trip create. G. So there's going to be visited create. So over here I'm just going to say if visited dot if visited I don't know, was visited Sudoku map, then return. That's what we do, right? So was visited, we just need to create the function which takes the thing, right? Dot inner I need to give it a reference to visited states, I guess. Right? Okay, we just do mut this, which is mutable t, and state, which is Sudoku map. This should return boolean. Does it not work? Expected type got error. So this is only 4 types currently. Can I do that? No. No. Okay, let's just say map then. Boolean is boolean. Mute visible visited states. Could not find visited states. There we go. So this is going to do what? We need to do a trip split. I need to like copy this thing, right? Map dot get or init and to copy this thing over here. And we are going to return yeah, this over here is the comparator that we need to do. We need to do the comparator. So I need to have a comparator. Comparator is a function which takes two Sudoku maps, returns Boolean. I guess this is like less. Right? We will need to implement this somehow. And if I implement this, then I can do this, right? So if less data value key and key data value state okay, and less than or equal is basically not less. If not less state and data value, then, right? Don't have parentheses here? What's the problem? No. Greater or equal is the trip. Oh wait, we have a... Why is it a trip of key values? That's wrong, right? Because I do here a singleton. Yeah, we do have singleton where the value is just the state. Okay, and then we yep. So over here we return false because it was not visited. Otherwise we return true. And in this case we actually mutate the thing. But I don't need to get anything from this. What's wrong here? Trip type T is not equal to this and that. Trip split. Yes, greater or equal is a trip of the Sudoku maps. Yes. Data is we don't know what data is. Oh, we don't have data value, right? Or do we? No. Data value, yeah. There's a reference to the data inside of the trip. State is the thing, and the value there should have the same thing. Left subtree, right subtree. I don't see the problem here. Hold on. Unit into so we have a function 491. Function is not equal to the trip less. Oh, because less in this case, yeah, okay. We have like a function less and we shadow it with the variable called less, right? Okay. Compare, I don't know, is less. Let's call this is less. That makes sense now. So we're using the trips, we're splitting the trip into like 3 parts, the less, equal, and greater or equal. Right? And then if there is no element equal to our state, then we actually initialize this state. Yep. That's all. So now we just need to implement the comparison function between the Sudoku maps, right? We don't have like the generic comparison of the lists, right? So let's say like like is list less, right? So this should be a generic function over t, which takes a, which is a list of t's, and b, which is a list of t's, and this should return boolean, right? And we also have like is element less, that's going to have the type t, so I have t and t into boolean, right? And that's what we need to implement. Okay, this should be easy, right? We just have here with return. So we just do for I in 0 to list length a. We return false because they are equal. But over here, if is element less list at AI and list at BI, then return true, right? Also, I guess, well, let's call this element B, and let's call this element A. Element A is this, element B is list at BI. So we do that, and also if not is element less element B, element A, or I guess if is element less B than A, then we return false, right? I feel like we want, like, this is going to be slow, right? We need to actual comparison. Do I need the actual comparison? Fine, let's do CMP list. Const ordering is, I feel like that's better, right? We have either less, equal, or greater. Let's do that. So we have compare list. This is giving me the ordering of the elements, and we give the ordering here. So we return equal here, but then we say that let element order is compare element CMP element, compare element list at AI, list at BI. I'm just going to inline it here. Element A, element B. So we say that if element order is not equal to equal, so if they are not equal, then we just return element order, right? That's how we do it. Not equal, this is not going to work, by the way, right now. So I need to say, like match element ord with equal, then we don't do anything. But if it is anything else, order, then we return order. I think we can inline this like so. Right? Does that make sense? Okay. So is less is basically if compare this and that is less, right? And over here, this is less or equal. If not is less, if So we just do compare, like, once again, data, value, and state. We want like less than or equal here, right? But I cannot. We're just going to match this, I guess, with, you know, less than left subtree, equal left subtree, greater than right subtree. I guess we just do this. Okay, and now the actual comparison. This will return the order. This just returns compare list. So we compare the list A, B. So we compare list A, B using the function. We're using the function which takes rows A and B and returns compare list A, B using compare cell, right? Type tuple, reference, and CMP element. Yeah, this over here. Compare element is this, right? Because we have this as a named argument. And over here we compare element as comparing cells. So compare cell is a function which takes references to optional integers, right? That's my cells right now in the Sudoku map. Let's see, we're just going to match A and B. If it is none and none, then I need this in parentheses, I think, right? Shit. None and none, and we just return equal. If we have none and some, then we return less. If we have some and none, then we say greater. And if we have some A and some B, then we return compare int 32 AB, I guess. Compare int 32 is AB. Wait, what is this? Why is there like 10 of these? I did not do that. We just return if A is equal to B, then equal, else if A is less than B, then less, else greater. Okay. So now we actually like have the thing, right? Unless... Okay, so now we should never see two equal states, right? And we actually perform the Sudoku solver. How long is this going to run, though? Wait, and that's it? Could not solve? Wait a second. This is all that I have tried. It's not even that much. Let's see if this works. Like, I need to try this for like not the input, I guess. Okay. Place is not initialized in 543. 543. Wait, which one? Which one is not initialized? Current solvable? So did I solve, but I don't have the current solvable? Is that what you're talking about? So I actually solved it in the example. So this does not work. Why not? I'm introducing this thing here. Okay, we have a huge stack trace. Place is not initialized. I'm trying to read the place. 543 13 to 55. So this thing is not initialized. Found solution. Wait, what happens if I do it like over here? Current part 2, current solvable, found solution, Sudoku map. Can I do that? Okay, so this like just gives me the original one. This works, but it does not work over here, current solvable. Is it because this is one is a let and the other one, like, does this need to be a const? This is just a type though, so I feel like it should not matter. But this actually changes something. Okay, sure. Sure, I probably should remember this and try to fix or something. Okay, so we actually solve, print solved. There you go. And this is the correct one, I'm pretty sure. So I still cannot solve input txt. I'm feeling some things. But I'm not feeling... But I cannot make more progress for some reason. So the only thing that I'm not trying like the palindromes, right? So the palindromes, I'm not actually like trying all the different variants of what can be a palindrome. But I guess I technically can. I guess technically I can. Will this fail if you have two of the same number in a row? What do you mean two of the same number in a row? I'm also not checking that like all of my things are correct. If the thing... So if, when I field something, I'm not checking that something is not correct here. Technically. So we have is Sudoku solved, but this can also be not correct, right? If contains, let's just say not is Sudoku solved. I want to know. Well, is Sudoku solved is like just checking that all of them are. Yeah. We already have like check returns boolean. Rule passes. This checks the thing, right? Yeah. Let's have a check map, check full, right? Which takes map Sudoku map, returns boolean. How about that? So we just do this, that, and then we do with return. We return true here. So this just checks that something is incorrect. Check. So if not check this, then return false. And if not check that, then return false. I saw that in a new paper once they printed a Sudoku that was wrong. Feels like no one double checked it before printing. Like you have 2 of the number 6 in the top row. Well, I mean, this is not exactly Sudoku. I'm calling it Sudoku because like that's what it is like. This is not exactly Sudoku though. We are solving liquidcake's advent of code. It has just different rules, right? In Sudoku, you say like that in a specific like line, you need to have every digit visited once, but we just have different rules. But in general, this is like Sudoku. Is there like a general name for the puzzles like Sudoku? If check full Sudoku map, if not, then just return. So we just skip the incorrect ones. Wait, what? Oh, wait, what? Well, I mean, I say false if it's not passing, right? Yeah. Number. Let number be this, right? If number is sum, and then, oh wait, not here, shit. Yeah, not here, in check full, this over here. This, I want this to be number. Let number be this. So only those numbers that are fully filled, only those I need to check, basically, right? So if number is sum, then we're going to test this. Okay, then we say that this over here is also a number. This is a capital number. If number is sum, could not solve. Let's say why is it incorrect, right? Number. dbg print c number. C number. A is 122. Well, I mean, wait, hold on, what? Why is A 122 though? Why is A 122? Because A is the thing that is just Well, let's give it I and J also, so that I know the position. The position is 0, 2. Position is 0, 2. In 0, 2, though, the position, the thing is B. It's not A. Hello? Print Sudoku map. Oh, I'm doing the input txt, right? That's why. Okay, maybe that's correct then. But in I0, this is 2. This is not 1 to 2. Because there is nothing there. Like, shouldn't this be none? Oh, I'm reading the number from digit map. Yes, but this should be okay. Yes, this should not be reading the number from digit map. That's right. I should read number from Sudoku map. Right? Sudoku map ij. From Sudoku map map ij. And this number is different then, right? Because this is a list. So, and this, you know, like, check, like 2 number, right? 2 number. Okay. So then, yeah, let's see, 2 number. 2 number has the list, which is a list of optional ints, optional digits, right? And this should give me option parsed integer, right? And stuff. Flat mode result is 0. Result. List iterate. List. Digit. Let's do with return. We will return some result here. But we say that match digit with if it is none, basically, then we return none, right? But if it is some digit, then we say that result is result times 10 plus digit. Okay, this does something now. Let's do this thing. Okay, this one is solved. And now the actual input txt is not solved. Okay. Why not? Oh my god. So this one is not solved. I feel like it's because it's not brute forcing the palindromes. Like, some of these things are never filled completely. What is my actual, like, input? Let's take a look. Input txt over here. So here's what we have. Like, so what we start with is this thing, right? So we know that this 40 is correct because, oh, I guess it's correct because of this C. So C is a multiple of 44, and we know, and we see that this over here is 440, and 440 is a multiple of 44, which is why we know that this is here. Okay, yeah, that's correct. So what is not correct? What am I not trying? Like, am I not supposed to... Like, I don't see in my attempts... trying to put something into, for example, G. But G is a palindrome. Okay, that's probably why. What about P? P is a power of 3. I think P maybe... I saw that. Let's print everything that I tried to do, right? So let's comment try and Sudoku map, right? Try feel. Try feel. Try feel over here. Since I filled, I want to print try feeling filled number is that. The struggle itself towards the heights is enough to feel immense heart. One must imagine Kupiman happy. What is that? According to based GPT. Hello, happy Nora. How you doing? Try feeling. I'm just going to say over here. To string C. Do I have C here? I do have C, right? With to string field number. Let's do that. No implementation of char. Yeah, I don't have a char to string, right? How do I convert a char to string? Hold on, string. Native string. Include string. Can I make a string from a character? I can just implement. Maybe I can do native to string C. Oh yeah, there we go. Okay, there we go. So we now see everything that we are trying to fill in here. Okay, well, I mean, my only guess is that we need to try to do the palindromes here. Also, I'm like panicking here with palindrome invalid, but yeah, I mean, okay, I guess. Oh, wait a second. I think this is incorrect, right? If field is some another, then unwind feeling none, right? So if, yeah. Yeah, we are... Yeah, this should never happen, basically. This should never happen. Because field, we have multiple ways of filling it, right? If field is some, this is not correct. This should not be here. This should not be here. This should instead be... like over here, right? This is me trying this feeling. Right? Then we do feel. So I don't do unwind, I don't do field here. This is not necessary. Field is not necessary. Try. Well, I mean, yeah, we don't assign this anymore. Oh, I have the entire branch of this. Yeah, because, yeah, okay. Because over here, we don't return anything here, actually, right? So palindrome is just checking. We don't return anything here. Field. Yeah, I guess we don't do this at all. I guess we don't do this at all with the return. Yeah, this is just me. Well, I mean, this is me feeling the palindrome. Hold on, no. Let's just do this directly here. This is feeling the missing digits. But I don't do some field, right? I instead say, like over here, by the way, field is as a list, right? This is field. Let's okay. Let's say here, let try is filled into this is what I need, which is number. I mean, yeah, this is bum. I need this over here before matching the rule, basically. So this try, yeah, we have like the acceptable range. This is me trying like an integer. Try filled, right? And over here we also just do try filled. Let's try running that. Inference error at line 411 with return. I guess I just returned here. That's all. Could not find field at 4. I mean, this thing over here. Yeah, we don't return anything. We just try. Fill the things. Okay, is this me trying too many things now? So I need to first fill in the obvious spots, I think, before brute forcing the other ones, right? But I'm not doing this right now. So like as an optimization to our Sudoku solver. Yeah, we need to like first fill the obvious ones. Oh no, but I've removed this code. Oh my god. Wait, how much time did it take Badcop to solve this? In Bash? Am I trying to do something wrong here. Yeah, like yeah, because right now I'm just brute forcing in order, but there are some obvious things that we can fill in, right? So there, this is try fill, but I should also try fill obvious first before going in, right? Maybe try fill. Try fill, right? Maybe try fill should. So right now it's just calling fill, right? But maybe we tell it how to like fill, you know. So these are all the different options. That, so we're just going to call this function fill with all of the options, right? Yeah. So we are just going to remember the arguments, and if we're trying to call it with multiple times, then we are going to ignore it first, right? Yeah, how about that? That sounds like a good idea. Right? So let's see here. With fill is fill into, so I'm just going to pass this as in the argument here. So we do with fill fill, but before doing with fill fill, we are going to do with fill with fill, let's call function f. So we are going to have function f, which is going to have like, so we have arguments, right? And then we with f. I mean, it is like in specific directions, right? Fill is f, like this is going to be a function which creates the thing, maybe. So I mean, in this case, we are actually yeah. No, I understand. F. Fill is f. No, hold on. Like, so try fill is going to call function fill with all of the different arguments of how we can like fill this specific position, right? Parenthesizing a sequence of statements, ABC instead of ABC is a camel thing, right? Well, not only OCaml, I guess. This over here is my language, but you do the same in OCaml, I guess. But in OCaml, you do a let in, let A be 1, in B, and in my language, you can also just say let A is 1 and then B. I guess that's the difference between me and OCaml in this specific case. Parenthesizing is just like, because everything is an expression, parentheses are just changing the priorities, allowing me to group things, right? So yeah, we just have an expression AB which just evaluates A and then returns B, You can put this in how many parentheses you want, just like with math. Bum 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 bum. Okay, how do you do this? So this try field is going to call the function fill with whenever we know how to fill this one, right? Okay. You know what? Let's do copy pasta for now. Let's do copy pasta for now. This over here is actually like performing the brute force right now. Right? This is actually performing the brute force. But before performing the brute force, I want to fill in the obvious choices that we can do. Right? So fill obvious is something like this. Right? And then if I like... Let's see, like I need to actually create the new field though here, right? Field obvious. Let's have it as a separate function, I guess. Field obvious of a Sudoku map. This is already 600 lines of code. Why am I trying to do this? Okay, so fill obvious is going to do this here. Fill is the function, right? So I'm trying to like see if there is an obvious way to fill this. So this function must be called exactly once. Then we do that. The function fill f must be called exactly once, and then if it's called exactly once, then we do that, right? So we say let f be. It's a function from arguments. So already called is none, right? We say that. So I guess we do like unwindable check obvious check. I don't know, let's do unwindable check. Called is none. Args. So if called is sum, then we just unwind check, right? And we just say then called is some args. That's what we do. And so now if wait, what is args? That is it, right? Called is some args. Data reference not data mismatch invariant. Oh, because it's some underscore. There we go. Yeah, so we like drew this. We remember the fact that this was called exactly once, right? So if called is some args, then we actually perform this filling. Right? When I perform the filling, do I just do fill args though, or do I do something else? This is just going to call it recursively. So I have found something that can be filled obvious in an obvious way, right? Yeah. Yeah, and I guess this returns a boolean whether there is something that can be done obviously or not, right? Right, so let field something is false. Sorry, should we say field something is true, and then we say field something. So if I could not field something obvious, then we will actually do the brute forcing. Now this needs to be done in this other place. Field something must be mutable. So I can copy paste, or I can say try at is, let's see, CIJDIDJ. This is what we do here, right? Try field sudoku map CIJ. This over here is going to be DI and DJ. So we're going to try at CIJDIDJ, right? Well, DIDJ is like 0, 1. And over here, we're just going to do try at CIJ10. Right? That's what we do. And over here, if I feel something, this actually means that I need to return now, right? Well, I guess we don't even do this because we're going to like recursively. Yeah, so this should be like false, but this over here just returns true. Okay, and now I need to call the field obvious, right? So I just say that if I did not feel any obvious ones in the Sudoku map, then we are going to do the brute force one over there, right? Try filling B with 99. Wait, what's the actual solution again? 2799. Well, I mean, yeah. A B with 99 should have been tried. This is B over there, right? This is B. This is 99. This is correct. But why did I not go further? Is it because I already tried that position? Feel obvious. Let's see here. dbg print fill print fill obvious dbg print args. All right. I mean, this is just 99. Yeah, but this is just 99, which is obvious, and this should say feel. Let's do it there. This is the one. Number. Can I just say here that number is this? Now this takes C. It would be nice if I had the C here, right? C. C. Try feeling B with 99. DBG print. Have not checked. DBG print C number. This is just check full. I don't need that. Try feeling B with 99. I mean, that's the correct one, right? Because this is the obvious way to solve this thing. Yeah, and the first obvious is feeling A with 27. That is the one. That is correct. C with 33. Yes. Yes. So like, yeah, we do all of that. It feels like I'm still trying like multiple ways of feeling B though, which is weird. Capital B. I try feeling this multiple times, like, but there should be another obvious thing to feel, right? All right, I'm starting to get lost in my code here. If not feel obvious, then we try the brute force. Let's see, print trying brute. Trying brute. Yeah, brute is like, that's when I'm trying the B, the capital B. But that should only happen if there is no obvious thing to do, right? Feel obvious. Try at Cij didj. We try feel this. That if called once, then we actually perform this, right? Let's print obvious, because we're going to print anything like something there immediately anyway, right? So what happened? So we're trying to solve this, and we have obvious A filled with 27. Then we have obvious C with 33. Then we have F with 27, which is obvious. Okay. Then isn't there still some obvious things in this example? I feel like example was still solvable with just the obvious ones, right? Like, we have this map. B is not obvious. I guess D here is obvious, right? Isn't it not? D is a square. And D is a square that ends with 14. With 4. So the answer is 64, which makes it a... Is 64 the only square? It is, right? Is there any other square that ends with a 4? So I should have tried filling that. But I did not. Why not? Well, I returned true here, that's right, though. D. Am I even trying it? Let's see here. Print, trying, obvious. Trying, obvious. See. There is try and obvious D. There is try and obvious D.
Hello, Bensk.
Bensk. Hello, hello. I'm almost done here, but so if I tried obvious, like D is obvious immediately. That's the thing, right? D is a square. D is a square. Let's go here. D is a square, which is 2 power of 2, right? So say here, if C is equal to D, then print dbg print cp wait, hold on, why does it say that D is 16? 16 is a square, but that's not the correct one. Try. That's not the correct one. Like, try. And then we call this try. Oh, I return. So I get, okay, this should be with return here, I suppose. So I should not actually do that because that's not correct. Because expect is not equal to actual, okay. Okay, there we go, now we have solved it. Okay, I found the bug. Does it mean that returning from inner functions is not that good of an idea and we should disallow that? I don't know. I feel like that's my problem though. Because I'm lost in my code anyway. Obvious. I don't want to see this log. Try and brute, I don't want that. Trying to solve. dbg print. I want to. Well, I mean, this is the panic, so it doesn't matter. This over here can be deleted. Okay, let's try on the actual input. Okay, it's going to solve it right now. Look at this. It's almost done. There you go. We have solved it. Nice. We have solved the entire puzzle. I mean, that's not the last thing, right? After finishing, ignoring the clues and wrapping, there will be a number of sequence of odd digits. Okay, so now we have a map. We now need to in every line to see the sequences of odd digits. And we need to add all of these together. And that's what we need to do. Okay, that's the final thing after solving. So the Sudoku has solved. I need to find the sequences, right? Okay. dbg print answer, but we need to do list iterate. We iterate the solved one, right? With so we have row now in every like line or whatever. So line is a list of optional ints, which are no longer optional, by the way, right? So we just say that let let like the number, like odd digits combined is going to be 0. But okay, we're going to say list iterate over line. We have a digit. We have a reference to some digit always. We are guaranteed that, right? Okay. We are going to say answer plus equal odd digits. And we're then going to say that if digit mod 2 is equal to 0, then odd digits is 0. We need to put this in parentheses, I guess. Otherwise, I need to, well, and also I need to say that answer plus equal odd digits. Otherwise, I just say that odd digits is odd digits times 10 plus a digit, right? I think that's how we do it. Let's try it on the example first. Let's print dot answer. Right, so answer is 2279. 2279, nice, okay. And now we do this on the actual input. And the answer is this. Your answer is here, .html. .html in this directory. Congratulations, that's correct. All right, yeah, this was fun. If anyone is interested in doing this yourself, if you did not have enough of Advent of Code, doing this from scratch is over here. This is a fun puzzle. This is more complicated than any of the Advent of Codes this year. And it took me in total of like around 5-ish hours to solve this. Did you do that with kast? Yes, this is my programming language called kast, which we use to solve this. This was I was writing here is my programming language. We have some like things that I would like to change, but in general, it's kind of nice working. Yes. It is done with kast. So I solved the entirety of the Advent of Code with kast already. And this is this puzzle, liquid cake of part 2. So basically by solving the Advent of Code and this, we basically, this is how we have tests for the programming language, right? So I have also like written this, which basically this actually tests the Advent of Code automatically, because we know the correct answers. We can invoke the solutions automatically and check that they are still printing the correct answer. That's how I know that the language still works, basically. And later, when we have the compiler, we will check that the compiler is working as expected by running the Advent of Code, I guess. Similarly, to check that it still is printing the correct answers. You like the syntax? Yeah, I tried to think about the syntax. Some of the things, though, I don't like. For example, this over here, this dereferencing, like it leads to a little bit too many parentheses. I think I will maybe like the fact that I can call the functions without having parentheses. I'm probably going to remove this, because when you call a function like fx and then you want to get the field, you need to surround this with parentheses, right? But if you try a language like Rust, then you just do fx.field, right? So you don't surround like it over there, which is better, especially like because I still require parentheses when I have multiple arguments. So now I will actually require like double parentheses instead of a single one, right? But if we require parentheses on the function call, then we can parse this properly. So yeah, and maybe some other things are going to change, who knows. What about flipped field access operator? What is flipped field access operator? When you have like field from object instead of object.field. Yeah, you can implement this into your own syntax extension. Like, is this useful? Is this useful? I mean, in a language like Haskell, your field is basically a function that is being called on your object, which returns you the field, right? I don't think we want to generate this as a function, though, but yeah. It is useful. I don't know. I don't know if I have ever wanted that in, like, Rust. So I guess one of the syntaxes that we could use, like field at object. That was suggested before, right? Although it doesn't work right now because I use at for like raw. At is used for raw identifiers, and it's used for raw keywords, which cannot be used as an identifier. So that I will need to change this to something else. We both said at. Well, it was originally proposed by Ray March using the at operator as the reversed field syntax. Alright, anyway, I guess I don't actually work on the language today, but we did solve the puzzle, which was fun. Let's be done for today. Hello? Where's my internet? There you go. Literally no one who I'm following is streaming, really? It looks nice. I'm going to check it out. Check out what? My language? I don't suggest you check it out yet. It's not ready. It's not ready. I mean, I have solved the event of code with it, but there are... I suggest you wait a little bit. At least a little bit. And at least until I start rewriting the language in itself. Oh, look at this custom compiler. Someone is making a language too. What is this? This is Zig? Oh, wait, this is Nim? What is that? It is Zig. Nim.zig? Wait, are they making the Nim language? I don't know. Alright, see you guys next time. Thank you for watching. Bye.